effect on the resultant protein. So the protein won't be produced properly or won't work properly. And we know there are about 23,000 pairs of genes in the human genome, and we get one of each pair from our mum and one of each pair from our dad. But we also know that occasionally changes can happen that aren't present in mum or dad that are inherited by the child. And that's largely what we're thinking about today. And these changes could result in a protein that has a lower level of activity than the normal protein, or a higher level of activity than the normal protein, or that behaves in some other way differently to the normal protein. And the ways in which that happens are often very poorly understood, even when we're thinking about, for example, RAS genes, which are perhaps the best characterised genes of the RAS-MAP kinase pathway in terms of their function. There's still a lot that we don't understand and a lot more that we can learn. And proteins are complicated not just because of how they're made from the DNA, but also because they don't work in isolation, so they're working together. And that's like the parts of an engine, really. A car engine isn't just one thing, there are lots of different bits, and it's important that all of the bits work in order for it to function normally. And when we're thinking about signalling pathways like the RAS-MAP kinase pathway, a lot of the things we're thinking about are kinases, and these act to control signalling. So one has a knock-on effect on the next and a knock-on effect on the next. So almost like the cogs in parts of an engine. And whilst these are things that we know about, there are lots of other proteins that are interacting with them and having effects as well. So that's why life gets quite complicated when we start to think about how these things actually work together. So it's a complicated picture, but actually what we know is that HRAS mutations result in altered HRAS proteins that give rise to Costello syndrome in the individual. You can see HRAS there at the top, sitting on the cell membrane, and actually abnormal HRAS results in abnormal signalling down the pathway. When we think about CFC syndrome, the commonest gene to be altered, as many of you will know, is BRAF, and that's sitting just downstream of the RAS genes. And therefore, when we discovered that these were the genes that were altered in these conditions, it wasn't that much of a surprise to realise that people already knew that they worked together. So the timeline for identification of these different conditions is over quite a long time period, really, but it was back in the 19th century that neurofibromatosis type 1 was first described. But then it wasn't until the 60s that Jacqueline Noonan realised there were a group of children in her cardiology clinic who had similar faces to one another and were short and had got a variety of different cardiac defects. And she coined this new syndrome that has subsequently become known as Noonan syndrome, which we now know to be due to mutations in several different genes. Jack Costello in the 70s described two unrelated children with a strikingly similar pattern of differences that we now know as Costello syndrome. And the new kid on the block, if you like, thinking about CFC syndrome, is a group of children who... Oh, I switched off. See, that's gone. Oh, did I hit it? Sorry, right, okay. Properly. So, a group of children with severe differences, particularly to their... I have witnesses now.
No, tell me the battery's flat. It is, it's got low battery. Why do I always have microphone problems?
Better go and get the technical card.
Right, so,
why does it need a microphone?
Okay, so I'll just shout, shall I, for the time being? So, recognising the similarities was something that had actually happened long before we knew what the gene responsible for these conditions were. And to such an extent that many patients who had a diagnosis of CFC syndrome might have turned out to have a Costello syndrome mutation, and perhaps more so vice versa, that patients with a diagnosis of Costello syndrome in the pre-molecular era, before we knew what the gene changes were subsequently discovered not to have an HRAS mutation, but in fact to have one of the CFC associated genes mutated. And across the group of disorders, there are significant numbers of patients who've got really quite intermediate phenotypes, and that happens even in neurofibromatosis type 1, where some of the patients have features of Noonan syndrome. So we've got within this group of conditions what we would think of as common disorders, because they affect perhaps 1 in 1,000 or 1 in 2,000 of the population. Those would be NF1 and Noonan syndrome. And we have rare disorders, Costello syndrome and CFC syndrome. And we know that Costello syndrome is only due to mutations in HRAS, whereas CFC syndrome, you have many different genes that we already know to be involved, plus a proportion of patients who we don't yet have a molecular reason for why they have the condition. And that's really where I'm coming from, that I think there are interesting genes to be found that are causing a CFC phenotype in patients, and hopefully if we can find those genes, that will be helpful in trying to understand better how these problems happen. So we've already touched on Costello syndrome as having been described in a pair of children by Jack Costello, and it was back in 2005 that the Japanese group identified HRAS mutations to be the cause of this condition. And it's characterised, as many of you will know far better than I, by poor feeding and cardiac differences, learning difficulties that often turn out to be rather milder than you would predict given the severity of feeding difficulties early on, and the excess skin on hands and feet and ulnar deviation of the hands. We know that growth failure and scoliosis are both common in this condition, and there's approximately a 15% chance of embryonal rhabdomyosarcomas in children who've got an HRAS mutation. So that is to say that we know this is far more common than would be in the general population, but actually there's still many more patients with Costello syndrome who don't get these tumours than who do. Noonan syndrome is the condition which Costello syndrome was described as being a Noonan-like syndrome, and it was not that many years previously that Jacqueline Noonan had described this larger group of patients with short stature, congenital heart disease, particularly pulmonary stenosis, and a characteristic facial appearance. We know that undescended testes are very common in boys, and then it wasn't until 2001, despite the large numbers of patients with this condition, that the first gene for Noonan syndrome was found, and that's PTPM11. And one of the reasons that it was so difficult to find the gene is that there are lots of different genes that can be responsible. So if people were looking in particular genes, there were a lot to choose from, and you might pick to look at the wrong gene in the wrong patient, if you see what I mean. But now that we know the molecular basis for around 3/4 of patients with Noonan syndrome, that's helpful, and diagnostic testing is available. And there's also been a lot of work recently to try and come up with guidelines for the management of Noonan syndrome, which is a challenge in itself because of its very variable nature. There's something much more interesting going on somewhere else. You're going to compete with it, do you think? Yeah. So, CFC syndrome, again, as many of you will know, is characterised by cardiac, facial and skin differences. And again,
you've got magical powers in there.
That's ventriloquism, isn't it?
Yeah, they are all that.
So, we know that a similar pattern of differences to those seen in Costello syndrome is quite often the case, but neurological outcomes are much more variable, and there's a high incidence of epilepsy, The skin and hair differences we've already mentioned, and also musculoskeletal problems. And whilst this is quite a long list, we actually don't understand terribly much about a lot of these at the moment. And again, that's another focus of my project, that I'm interested to know more about what are the biggest problems for this group of patients. And clearly that's where you guys can come in terms of trying to let us know what are the main differences and difficulties for these children. And that's something that we've got a clinical study trying to collect as much information as we can on this group of patients, which I know that some of you have already been prepared to contribute to, and there'll be opportunities to talk later about that, and hopefully there might be other people who'd be happy to share some clinical details about their little ones. We know that BRAF is the commonest gene to cause CFC, MET1 and MET2 and KRAS each accounting for a small proportion of patients with this sort of phenotype. And when we get into thinking about other conditions, a much milder condition is something called multiple lentiginous syndrome, which was known as leopard syndrome because of this complicated acronym. So the lentiginous are the dark freckles, E for ECG abnormalities, O for ocular hypertelorism, meaning wide spacing of the eyes, as we see in many of this group of conditions, P for pulmonary stenosis, again as we see in many patients across the group of disorders, A for abnormal genitalia, R for retarded growth, and D for deafness. Now actually a lot of patients with the mutations in PTPN11 that we know to cause this don't have nearly all of this list, and again, along with the idea that actually leopard syndrome is not a label that everybody would find acceptable, we think of multiple lentiginous syndrome as being a much more practical way of describing it. We know there are some patients with very much this pattern of differences who don't have an identified mutation at the moment, very much like the case for Noonan syndrome. And NF1 and Legius syndrome, I'll just touch on briefly, as much of what we've learnt about the pathway disorders has been because NF1 has been recognised for such a long time, and we've known now for over 20 years what the gene fault is for this condition. And whilst gene testing isn't something that's been done for a long time because it's a very big gene and it's very difficult to test, and people could be diagnosed successfully clinically, now that we're identifying ways of testing for gene changes that are so much more efficient, more families are having the testing done, and we're identifying more variety in how badly affected people might be with this condition. And there are some families who we know have got related genes altered. So the NF1 gene is normal, but this gene called SPRED1 can cause a pattern of differences that's very similar to NF1. And again, they have some similarities to Noonan syndrome as well, these patients. And so it's all sort of falling into place. And the reason that NF1 is important in this context is because it's a large group of patients who've been studied over the years because they have a clearly recognisable phenotype. The Noonan syndrome phenotype is a lot more diffuse and a lot more difficult to pick out because a lot of children who've had congenital heart disease, for example, might have short stature as a result of having had lots of surgery when they were small or being poorly in childhood. And so ascertainment is a real problem, whereas the NF1 cohorts are perhaps a lot easier to identify, and that's been the source of some very important information over the years. It's a common condition, and there's an increased risk of a wide variety of tumours. But like the other conditions in this group, we know that half of people with this condition are the first to be affected in their family. So that's all right. We're back. Fine. And features that we know to be in common with other RAS/MAP kinase pathway disorders are short stature in a high proportion of patients, so this is often quite mild in NF1, relative macrocephaly, that is to say a relatively large head size, and 50% of patients have some learning difficulties. Though again, these are often quite mild. It's important because we know that this is something that is recapitulated by mouse models and other animal models of this group of disorders. And again, when we get to thinking about treatments for NF1, there is the question as to whether they might also be applicable to patients with other related disorders. So when we were thinking about Noonan syndrome and variants where we didn't know what the genetic basis of the condition was, there were a group of patients that by an Italian group were found to have a particular mutation in a gene called SHOC2. And these were mutations that weren't present in their mum and dad, very much like those that we see in CFC syndrome and Costello syndrome. And the patients had quite variable features, as you can probably hopefully just about see projected in some of them. But growth hormone deficiency was very common. And the other thing they had was this unusual hair, which was quite sparse and tended to fall out. So often children were about 6 by the time they needed their first haircut. And whilst this was initially described in a group of patients with a Noonan type presentation, this made us think that actually perhaps some of our patients with more significant skin and hair features and short stature and feeding difficulties might also have changes in this gene. And so we went looking in our cohort of patients who'd had samples referred in for Costello and CFC testing, and we did indeed find that this appears to be quite a common cause of a CFC or Costello-like phenotype. And across the group of patients in whom we found this single gene change, we found that feeding difficulties and very short stature are extremely common. Significant skin and hair differences definitely seem to be the case. And we found that actually people could be referred as query Costello or query CFC and turn out to have a mutation in this gene. So that again is really important, and that's now clinically available testing that we know of several patients who benefited from that. So overall, how common are this group of conditions? We think that there might be 1 in 1,000 people in the population overall who have one of these disorders. So that, in terms of genetic conditions, is really pretty common, and that's an important patient group for us. We don't actually know how common Noonan syndrome is, and that's because at the mild end, it may well remain undiagnosed, and at the severe end, it could well be thought, well, does this person have Noonan syndrome or CFC syndrome? We know that CFC seems to be quite rare, but is definitely more common than Costello syndrome from the patients that we see referred for testing in our lab. But the commonalities across this group of disorders are that there's a significant lifelong disease burden and specific complications for which we should be alert across this whole group of patients. And so some work that Bronwyn's done recently to try and work out how common Costello syndrome is. In order to know how common something is, you have to be sure that you have a good way of identifying all of the people with this condition, and actually testing for HRAS mutations is confined to 2 centres in the UK, and if you don't have an HRAS mutation, you don't have Costello syndrome. So that gives us a good way of actually trying to be accurate about this, and the latest estimate would be that it's about 1 in just under 400,000 people who are born with Costello syndrome. And you can see here that we know of about 30 patients in the UK so far, and of those who haven't survived, actually the greatest degree of problems has been in the first year of life. So actually not making it out of the neonatal unit or dying in very early babyhood is the most common reason for not surviving. There were 3 who'd had a rhabdomyosarcoma, which we know to be a significant thing when it happens and associated, unfortunately, still with treatment difficulties. And there were a couple of others who'd had respiratory problems or an unexplained sudden death. But overall, it's definitely that babyhood appears to be the greatest risk period for mortality. And we haven't got similar figures for CFC syndrome because of not having a neat way of defining exactly how big our patient group is. because we know there are lots of genes and we know that there are patients who we definitely think have got the condition who don't have an identifiable mutation, it's difficult to know where to draw the lines. But hopefully as we understand more, we'll start to be able to get some better data about that too. So, I've already talked about that really, and the idea that actually a clinical study of CFC syndrome would be something that we could help us better understand the problems that people with the condition have, and perhaps how best to manage them. So that's something that I think is really important. And there's been great work done in Costello syndrome, and some of the systems that have been devised from that perspective may well be applicable to the CFC group. So the other thing we're thinking about is whether there are specific patterns of differences about thinking and learning. And work in children with neurofibromatosis type 1 and in fact animal models of various of these disorders suggests that this might be the case. And for NF1 there are already children who are in clinical trials for whether medicines that we know exist already might improve their learning and attention. And so if there were to be similar patterns in the way that people with Costello syndrome and CFC syndrome think, then actually the same treatments that are being tried in NF1 might be an appropriate thing to think about in these other disorders of the pathway. So that's something that we're taking forward with a study of psychological profiling in Costello and CFC syndromes. And this is something that Anuka, who's here with us today, I don't know if you want to stand up or wave, Anuka, who's a psychologist with us in Manchester, has been working really hard on getting a way of doing this, having already got experience of working with the NF1 patient group. And again, this is something that we feel could be really valuable data, and if there were people here today who were interested in finding out more, I think Anuka's here till 6 o'clock this evening. Obviously Bronwyn and I are here all evening as well, so we'll hope to speak to as many of you as people would be interested. So, in summary, we know that there are common features to many disorders of the RAS-MAP kinase pathway, that feeding difficulties are a big issue, short stature and growth hormone deficiency are pretty common, and that skin and hair differences are something that we see especially in Costello and CFC syndrome. In terms of heart problems, that's something that I think we're going to hear more about very shortly. And there's a variety of differences that we know to be more common in this patient group than in people in the general population. We know that learning difficulties are very common in CFC and in Costello syndrome, and we think that there may be characteristic behavioural profiles, but again this is something that we think needs further work in order to try and work out whether that's the case. And across this patient group, really, de novo mutations are those that are present just in the individual rather than being present in their parents are common, and that the mutations that we find generally seem to show some demonstrable effect on RAS-MAP kinase pathway signaling, suggesting again that if there were agents that would affect how the pathway signal transduction works in the cells, that might be something that we could actually target in terms of trying to improve some of the features that are present in this group of conditions. So I'll just finish with a little bit that some of you may have seen in the CFC Chronicle from April this year. A little girl who's not so little now, I think she's a full-fledged teenager, who'd had 15 years of what her mum said, doctors, hospitals, pain, tears and doubt, but finally a diagnosis. And she was one of the individuals in whom we first identified a SHOC2 mutation. And you can see perhaps there she's an absolutely gorgeous looking little girl, I think, but she has got some similarities to the Italian patients who were reported in the original paper. So I think it just remains for me to thank various people who've helped me with putting together my talk. Obviously, Roman, the main bod, and I think there's a little tissue recognition that some of the people who were at the zoo last year maybe have got the, again, I think I pinched that from the CFC Chronicle, didn't I? So it's nice to see that there are some people here again today who at the meeting last year.